Hey guys, welcome to my channel. This video is on Further Statistics 1 Exercise A, question 6 to 9. So let's get started. Okay, so the question is, the random variable x has a following probability distribution. Given that e of x is 0.3 and e of x squared is 1.9, find a, b, and c. Okay. So as usual, and as you know, we start this question by writing the expected value of x, which is 0.3, and we follow the same process again. So 0. minus 2 times 0.1 plus minus 1 times a and 1 times b plus 2 times c, which is equal to 0.3. Okay, and now we just need to simplify that in order to get an equation which has two unknowns. So minus 0.2 minus a plus b plus 2c is 0.3, and the next step is minus a plus b plus 2c. Oh, the equation has three unknowns, sorry. And this here will be 0.2. Okay, this is the first equation that we get. And we can get the second equation by just using the fact that the sum of all of these probabilities will be equal to 1. So 0.1 plus a plus b plus c is equal to 1, and a plus b plus c equals 0.9. Okay, this is our second equation. And easily we can find the third equation by using this piece of information, which is expected value of x squared is 1.9. So we just need to just draw a new table, which will be for x squared, and p of x squared equals x squared. So we just need to square that, but the probabilities stay the same as usual. So here will be 4, 1, 1, and 4 again. So here will be 0.1, A, B, and C. Okay, if you find the expected value of this part, we will do 4 times 0.1 plus A times 1 plus B times 1, and 4 times C is equal to 1.9. We just need to simplify this in order to find our third equation. 4c equals to 1.9, and a plus b plus 4c will be equal to 1.5. And now we have three equations with three unknowns. So the last step is just using our calculator, the equation solver function, and we can get the values of a, b, c. So the answers are a is 0.3, b is 0.4, and c is 0.2. Okay, this was the sixth question, and it was pretty straightforward. Okay, next question. Question 7. The discrete random variable x has probability function this. Given that e of x equals 1.2, find the value of a and the value of b. Okay, as usual, we need to draw a table, and okay, so the values we have for x are -2, -1, 0, and 5. Okay, And now we just need to use this probability function in order to get our probabilities, and then doing the also the next steps which are the same as the previous questions. Okay, so here 1 minus 2 is 3 times a, which will be 3a, and here 1 minus 1, and this is 2, and here will be 2a, and again here will be 1 minus 0 times a, and here is b. Okay, now as we know the expected value is 1.2, so we need to use this rule again. Minus 1 times 2a, 0 times a, plus 5 times b equals 1.2. And then we need to simplify this in order to get an equation. Minus 6a minus 2a plus 5b equals to 1.2. And let me just separate this. So, yeah. Okay, and now minus 8a plus 5b equals 1.2. So this is our first equation. And in order to get the second equation, we need to use also the fact that the sum of these probabilities is equal to 1. So 3a plus 2a plus a plus b is equal to 1. And as you know, we just need to solve these two equations and we will get 0.1 for the value of a, and b is equal to 0.4. Okay. So feel free to have a go at this question, because this question is a bit different from the previous questions. A biased six-sided dice has a 1/8 chance of landing on any of the numbers 1, 2, 3, or 4. So, and the probabilities of landing on 5 or 6 are unknown. The outcome is modeled as a random variable x, given that e of x is 4.1. A. Find the probability distribution of x. Okay. So as you know, we need to draw a table again in order to find the probability distribution of x. So p of x equals x and has a 1/8 chance of landing on. Okay. So 1, 2, 3, 4, 5, and 6. Okay. Um, so the probabilities are 1/8 for 1 to 4. And the probabilities of landing on 5 or 6 are unknown. So we just write 8 and A and B. Okay. So we have the expected value of x, which is equal to 4.1, and the question is asking for the probability distribution of x. Okay, so we just need to again use the two methods, the two steps that we were following in the previous questions. So the first one is just using the fact that e of x is equal to 4.1, and let me write that here. So 1 times 1/8 plus 2 times 1/8 which is equal to 4.1, and also using the fact that the sum of all of these probabilities is equal to 1. So we just write like this, equals to 1. And by solving these two equations, we will be able to get the values of A and B. So A is equal to 0.15 and B is equal to 0.35 or 0.35. Okay, so this is the answer needed for part A. And now we're going to do part B. Okay, I'm going to do part B here because it's not that long. Okay, the dice is rolled 10 times. Calculate the probability that the dice lands on 6 at least 3 times. Okay, if we read this question carefully, we will find out that this is a binomial distribution because we have fixed number of trials, and if you read this carefully, you will find out that this is a binomial distribution, and here is our n value, which is equal to 10, and also um, because we have the probabilities now, and so we know the value of p, because here said that on 6, so when is set on 6, we need to use the value of b, which is equal to our p value is 0.35, and our x value is 3 because it said that at least 3, so x needs to be equal greater than 3. Okay, so x is distributed binomially, and 0.35, and we need to find the probability of x being greater and equal to 3. So we can find this by doing 1 minus p of x is smaller or equal to 2. And then by doing this and using your calculator, the binomial CD function, you will get 0.7384 to 4 decimal places as your answer. So this is the answer of part B. Okay, now question 9. Feel free to pause the video and have a go because this question is interesting. George has designed a game for his school fete. Students can pay £1 to roll the first 6-sided dice. If they score a 6, they win a prize of £5. If they score a 4 or 5, they win a smaller prize of £p. By modeling the amount paid out in prize money as a discrete random variable, determine the maximum value of p in order for George to not make a loss on this game. Okay, at first we can kind of write everything down and write every words in numbers so we can understand the question better. And we can do this by drawing a table which can summarize all the information. So we can write here a score, it's probability and price pounds. So the scores are 1, 2, 3, 4, 5, 6. And the probability is 1/6 for all of the scores because it's the first 6-sided dice and a discrete random variable. So 1/6 for all of the scores. And the price, according to the question, is only p if they get 5 or 4, and £5 if they get 6. But for the rest of them is 0 pounds. Okay, now we can convert this table and the useful information into a probability function and probability generating distribution in order to use this information. Or we can just convert that into a table, okay, instead of converting that into a probability generating function. We can convert that into the table directly, and there is no need of doing that. Okay, let x be the amount paid out in prize money. Prize money. It's a bit messy, sorry. And now we draw this table. So x, and this is the probability. So x can be 0 or p or 5, because remember that we are using this information. And for the probabilities, probability of getting £0 or winning nothing is a half, because here 1/6 plus 1/6 plus 1/6 is equal to a half, and probability of getting £p is equal to 2/6, which is 1/3, and probability of getting £5 is here, which is a 6. Okay. And now the next step is finding the expected value of this table. So it will be 0 times a half plus p times a third plus 5 times a 6, and expected value equals 1/3 p plus 5/6. And here's the thing that you need to extract from the question. And if you just notice to this hint, it said that the expected profit from the game is the cost of playing the game minus the expected value of the amount paid out in prize money. So what this means that the question is asking for the maximum value of P in order for George to not make a loss on this game. So this means that the expected profit from this should be 0, because this is the highest amount of P that can be, and by having this amount of P, George won't make a loss. And also this is the maximum, because the maximum amount of P is when George doesn't make a loss. Expected value is 0 because this is the expected profit from the game. And if we want to find this, we need to use this piece of information from here, or piece of hint, it's better to say, that 1, because 1 minus 1/3 p plus 5/6, and this is equal to 0. So this is because this is the expected profit from the game, and this is the cost of playing of the game. Here is £1 minus this is the value of the amount paid out in prize money. So by using this equation, we will get the value of P, which is 0.5 pounds, and this is the maximum value of P that George can make without making any loss on this game. Okay, thanks for your time and watching this video. Please subscribe for more videos, and see you next time.